Sir, I'm audible? Okay.
Good morning.
Morning, sir. Hope all interested candidates are joined. It's time to, okay, we will start today's session.
Sir, good morning, sir. Pawan Kumar. Sir,
Sir,
good morning.
good morning, sir. Yes, sir. Good morning, sir.
Good morning, sir. All right, sir.
Okay. So, good morning, all the participants for the day 3 session of this FDP. Okay. So, welcome. I welcome all of you on day 3. So, we will start today's session without wasting the or more time. So, I'm sharing. Sir, my slides are visible? Visible, sir. Okay. So yesterday and the day before that, till now we have covered the functions, flow control, line plots, image, and basic commands and debugging. Okay, how to make efficient code. After that, linear algebra, polynomials, integration, differentiation, and basic commands, which are generally or most commonly used in the MATLAB. Okay, so today we will start with some mathematical probability and statistics, mainly statistics, and some basics of that data structure, how we can manage our data in MATLAB, and how we can modify the images, and how the input and output of the files in MATLAB can be taken care. Okay. So as far as we are moving ahead for statistics, you can see we can analyze or compute the statistics of a number of data in MATLAB. Okay, so variance, mean, average, median, mode, and histogram can be plotted in one command. Okay, so there are built-in function. There are built-in function of mean, median, and mode are available in MATLAB. Okay, so this group data into the histogram. What histogram shows? Histogram shows the bins of the number of data. Suppose 100 data is present over there. So it will make a bins of that data. Okay. So I will show you with some examples, or I will write with, for this one. Suppose we are making scores. So maybe it may be not possible for you hands-on. So I am giving the live experience for this one. So how to use these statistics also. So for scores, I'm creating a variable scores which contains 100 into 10, 100 into 100 multiplied by random data between 1 to 100. Okay, it will be saved in score. It will be a random data. Okay, so it came in scores. Now I want histogram of this data stored in this one. Okay, so what I will do, I will just write hist, this command available in MATLAB, hist scores 5 to 10 to 95. Okay, so it makes a histogram with bins centered at 5, 15, 25, and with the steps of 10, like we are making some line space. So it will distribute this data between 5 to 95, right? The data available between 1 to 100, between 5 to 95 with a step of 10. Let me copy this if it is allowing me. Okay. So this is the histogram. Okay. So now it made the data which is available here. It is making bins of this is 5, which contains count of 12. This is 15, which is contains a count of 7. Then 25, which is contains the count of 8, and so on. Okay. So you can see the bins are showing the up and down structures because each bin contains the different count. Okay. So this is different from this hist is different from the bar. Okay. So if I give the second command like hist score 20, so what it will be, the output will be. So we can check it. Now what it is doing, same output we can get from this one. Okay. So what is showing, we can say count of 7. Okay. Centered at 76. Count of 10. Okay. Count of 10, 4. Count of 5. Count of 7. Okay. Different count it's showing. Okay. So next is hist-C. Okay. What is the use of this hist-C? It returns the number of occurrence between the specified bin edges between 0 to 10. Okay. Between which is greater than 0 but less than 10. Then greater than 10 but less than 20. Then greater than 90 and less than 100. Okay. You can plot this manually also with this bar. Okay. Bar is different from the hist. Okay. So now we can also generate the random numbers of what we want between the limit. Okay. So we can use rand 0 to 1 for the uniform distribution between 0 to 1. Rand n draws from the standard normal distribution, Gaussian distribution. Random will give you the can give random numbers. Many more distribution are possible. Okay. So we can explore this with the help random. If you type help random, so it is possible to get the details about this. Okay. In MATLAB. Commands like rand or rand1 or many more commands are available which are related to rand. Okay. Now changing mean and variance, how we can change. Okay. So if I am giving a command like y equal to rand 1 to 100 into 10 plus 5. Okay. So what it will give me, it will give me 100 uniformly distributed number between this 10 and 5. Okay. Sorry, 5 and 10. Okay. It will give me random distributed data between this 5 and 10. If I will give floor rand 1 comma 100, okay, just a minute. Maybe tell him to drop it story. Okay, so rand floor cell is to round off this data. Floor and cell can be used for the round off the data. Okay, if it is showing some decimal point. Okay, and rand I also can also commands you can explore with the MATLAB. Okay, I'm just giving you an idea what are the possibilities available in MATLAB. These are some exercises. Okay. Now let's talk about some data structure, how we can manage the data in MATLAB. Okay. So we have used 2D structure matrix. Okay. We have used 2D matrix can have n dimensions with RGB images. Okay. Red, green, blue images. Red, green, blue images. Okay. So every element must be the same type. It may be an integer, it may be a doubles, it may be a characters. Okay. So matrices are space efficient and convenient for calculations. So it is very easy to handle them. It is very easy to handle. Okay. Large matrix with many zeros can be made sparse. More on this later in this lecture we will discuss. Okay, so there are two types of structures available in MATLAB, mainly cell array and structs. Okay, so it's like an array, but elements don't have to be the same type. Okay, it may be different type. So first one is the matrix, then cell array, then structs. Okay. So matrix contains only numbers and integers. Okay. And cell array may contain some names, integers, and some attributes of this matrix also. And structs may contain cell array and matrix both. Okay. Can array both. Okay. So you can see here a matrix which contains the positive or negative values of number. But unlike in cell array, you can see 3 by 3 cell array, which contains some names, okay, or some numbers. And in cell also, it is possible to be a matrix more than one in one element. There are possibility of one matrix also. Okay, so one cell can contains the names, ages, and ages of their childrens also. Okay, to do the same with matrix, you would be need three variables and padding. Okay, so initializing a cell can specify the size. So 3 comma 10 can be a size of a cell. Okay, which contains 3 rows and 10 columns. Okay, so unlike a matrix in which we are showing it with a square bracket, cell can be fixed with the curly braces. Okay, so this curly braces can be used for cell. Okay, so you can see hello world is this in between this comma this matrix and rand 3 comma 2. So C is a cell with one row and three columns. Each element of cell can be anything. Okay, element can be anything. So to access the cell element, use curly braces. Okay, so A1 comma can one, this matrix will be in the cell array format. Hello world 2 will be in the cell array format. Okay, so like this we can initiate the cell. Okay, so this is the basics from the cell. Now struct allows you to name and bundle relevant variable. Okay, so structure which are containers with fields. So main number of fields are also possible. So to initialize an empty structure, just type is s equal to struct. Size will be 1 comma 1, and initialization is option but recommended when using large structs. Okay, so it can be any field. S dot name, it can be Leo. S dot age, maybe the age of that Leo. S dot child age in a matrix. Okay, field can be anything, matrix, cell, or even struct. Okay, this is useful for keeping the all the number of variables together. Okay, so for more information, you can go through the help struct if you want to know more about this one. Now, struct array. What is a struct array? So to initialize a struct array, give field or values of pair. Okay. So this is one example over here. So you can see over here, name of the people are given John, Mary, and Leo, and their age can be defined over here, and their age also can be shown over here, 2 comma 4 1 over with the with the help of matrix. Okay. So representation of a structure array can be shown over here, struct with the bracket name in the second after the comma you can write the name, then age of these peoples can be written 32, 27, and 18. So you can see over here, then child's age in matrix from 2 semicolon 4 comma 1, and then a matrix, empty matrix. Okay, the size of people will be 1 comma 3. This can be stored in this one. Then every cell must have the same size. Okay, then you can create the people person for people too. Okay, person is now stuck with the field name, age, and children. The value of field are second index into each cell. Okay, so this is the basics from the struct array. Okay, so we have seen over here what cell array and struct array. how to access these structs? So it can be given a name of the field stu equal to s dot name or a equal to s dot age, which gives us 1 cross 1 structs that are useful when passing many variables to a function. Put them all in a struct and pass the struct. Okay. To access n cross 1 struct, use the indices. Okay. Particular indices can be used for like a name, age, and child age. Okay. So particular name can be used. Okay. These are the basic exercises you can do with the struct. Now, how we can handle the images? So, like we plotted yesterday, so images can be handled in this way. So, what we can do this, let's plot this one, manipulate the graphics using object using handles. Okay, let us plot this one 1 to 10, random 1 comma 10. Okay, so what you will get? You will get a plotted line or current axis by giving this GCA. Okay, by giving this GCA, you will get the handle for the current plots. It will give you just a line with the simple plot. GCA will give you the handle for the current axis. You can access the you can manage the axis by GCA. Then GCF. Okay, GCF used for the current figures. Okay, so to see the current property values, get L. Okay, get L comma Y data. For some data you want to handle some images and something, you can and use by this one. To change the properties, use set. Okay, yesterday also we discussed the name, font name, face color, what you font name you want to change, Arial or Times Roman or Calibri something, access scale, log you want to change. Okay, line width you want to change 1.2 to 5 or more thicker or more smaller you want to change, marker type you want to change. So this can be handled. Okay, and images can also be read by the MATLAB. Okay, not only plots. Okay, so for that one you have to just write this command im read and name of this picture which is available in JPG format. Many formats are available with the MATLAB. So it is just an example of this JPG image. Okay, so it will show you im show uh, in bracket im. Okay, so MATLAB support almost all formats as I told you: JPG, TIFF, GIF, BMP, okay, PNG. Okay, for more reading options, you can go to the help im read. Okay, pixel format types, these are also available in MATLAB. To write an image, give RGB matrix 0 to 1 doubles or 0 to 2 to 8 uint 8. Okay, I am right to write an image rand 30 comma 30 comma 3 TL T1 comma JPG. Okay, so it can be written as image. Okay, so you can export with im read and im write, help im write. So these are MATLAB some built-in images which are available with the MATLAB. So you can see TIFF tiff format dot png dot jpg dot png. Okay, these formats are possible in MATLAB. You can import and also you can save in this format. Okay, so how we can take input and output of files in MATLAB, it is also important. So importing the data is also an important function of any software. So if you want to import some data in MATLAB, just give import. Okay, just import command in the bracket. Just write what is your file name dot txt. Okay, dot txt file. It can be imported in this MATLAB. Okay, dot data can also be imported. Okay, and some different format also possible in MATLAB. Okay, so you can just write import data and in the bracket in the inverted comma you can just write file name comma what is the means extension of that file .data.txt, it can be imported in the MATLAB. Okay, so import data is very robust, and but sometimes it can have trouble to read files with more control. Use fscanf. Okay, this is similar to C language in Java, or text scan. Okay, see help information if you want to explore this section. Now writing Excel files and import, and how to write, how to import the Excel file. Okay, so like we are importing the images, we can also write and read the Excel files. Okay, so use XLS write. Okay, a random numbers from a ren 10. Okay, so it will write as XLS file. Okay, so sheet name and range, it is option. Okay, so you can also write a cell array if you have mixed data. Mixed data means some numbers, names also are there, so it can be saved in the Excel format. Now I want to read Excel file. So you know, a Microsoft Excel file are generally stored in this .xls format. Okay, so you need to just write the name of that file with the extension XLS, and give this XLS with the file name .xls format. Okay, so it may be a number, text, or some raw material which is available in Excel file. It can be imported in MATLAB. Okay, it can also be possible to read the mixed data in MATLAB. Okay, just if you want to remove some data also, it is also possible. Okay, so help XLS read. Will you, if you want to explore more about this one? Okay, this is the option available in the MATLAB. Okay, so it can read any file. Okay, to open from a file, use fopen. Okay, if you don't know the format, or format is not possible like XLS or data format, so just fopen file name. Okay, comma r. Okay, return a handle to a file. Okay, fread also possible for data, for some data. Okay, fread in bracket fid comma 10. Okay, this reads the next 10 bytes from the file. Okay, so if this comma 10 is given, it will read only 10 bytes from the file, and it shows them in data. fseek also available. So give the file name fid comma 5 comma 0, move forward 5 bytes from the current position. More commands also available in MATLAB like fopen, fread, fwrite, ftell, fseek. Okay, for more information, you can go through this also. So this is one section, one brief section we completed over here, in which some basics of statistics, data structure, images, and file input output we have seen. Okay, now we will see some. I will skip some of the points in this one, because some are not important or very complex to study. Okay, because it is not possible to cover all the topics. Okay, so you can also make and just briefing about this one. Okay, so repeat matrix command can create replicas of matrix. Okay, you can just write repeat matrix. So this matrix can be repeated in 2 comma 2. Okay, so execute parallel using command parl is also part .pl file can be imported. Then miscellaneous MATLAB commands are also available over here. Now making GUIs. Okay, you can make your own GUI by using this MATLAB. Okay, you can go to just type guide, select blank GUI, and make your own GUI, graphical user interface, using this MATLAB. Okay, so it will be a blank file open in front of you. You can draw the GUI. Change the object settings. Okay, draw your images axis. Okay, according to your need, what you want to show for the user. Okay, You can save your GUI, okay, with the help of this save as command. Okay, add functionality to M file. You can add functionality to the M file. Okay, functions we already discussed. Running the GUI, then help GUI help function. Then important is Simulink. Okay, so this is very important toolbox available in MATLAB. So MATLAB Simulink is nothing but it is also a programming. Like in generally M file we are using some codes. So unlike that one, Simulink, the inbuilt boxes or small boxes which contains the functions are already in the form of block diagram based on MATLAB environment are add on in this Simulink. I'm showing you how we can use this. So in this home only this Simulink is available over here. Okay, so you can click on this one. Okay, so this type of interface GUI will come in front of us. Okay, so what we can do this if you want to make a new um, new Simulink model, just click on this create model. Okay, go to this create model. Just go to this create model. A blank model will come in front of you. Okay. Okay. So this kind of blocks, okay, so you can see the MATLAB package is useful for linear system analysis. Simulink is for more useful for control system simulator. Okay, so PID controller can be designed using this one. Mostly electronics people use this Simulink very well. Okay, so Simulink enables the rapid construction and simulation of control block diagrams. The goal of the tutorial is to introduce uh, of Simulink of control simulation system simulation. Okay, so we can see in this live example we will see when we go to library browser. Okay, in the library browser you see lots of inbuilt blocks are available over here. Okay, so you can see over here math operations can be done by this. Okay, plus minus division and multiplications. Okay, continuous functions. Okay, discontinuities, discrete lookup tables. Okay, sinks, sources. To explore more you can go to sinks. Okay, sorry, first we will go to sources. Sources, these are the input blocks which are available here. Okay, so you can give a input as constant. Okay, it may be a input. Okay, it may be a ramp input, it may be a step input, it may be a sine wave. Okay, like this we can give as a input. Okay, then sinks. Sinks can be used for the display purpose. Okay, like the display floating scope, or you see the output scope. Okay, so this can, or XY graph, this can be seen in the sinks. Okay, so source and sinks, these are the important. Then if you click on the and these blocks, you will explore all the things. Okay, bus creator is there, so one block is coming from here, second block is coming from here. It can be joined by bus creator. Okay, a constant or any input can be joined by this bus creator. Okay, so these are the commonly used blocks are shown in this first one. Continuous will be show a in between block between source and sink. Okay, so these continuous block can be used in this sink and source. Okay, so you can see over here controller, PID controller is there, integrator limited is there. Okay, integrator is there, second order integrator is there. Okay, integrator and second order limited is there, derivative is there. So like a M file which we are using in MATLAB, here with the help of block we can use this Simulink. Okay, so I'm showing you one example of PID controller. If you want to if you want to draw with me, just you can draw with me, or I am seeing it is already available is there. So I will directly open that one. So here is the templates and library available here in the this Simulink block. Okay, so this is for debugging, this modeling format, and different apps are available in Simulink also. Okay, just wait. Here you can see the number of recently opened file are there. Okay, so you can see PID controller over here. PID controller is available here. So I'm just opening it. Okay, so this is simple PID controller which is made in Simulink environment. So how it was made, I can show you one with steps. So you can see here. Okay, so this is the PID controller design using Simulink. Okay, so what is first of all, what is PID controller? PID controller is proportional integrative derivative. Okay, which can be generally used for the industrial purpose or controlling any algorithm for all. Okay, for example, when we feel cold and turn on our heater on, we form a feedback loop. Okay, so if we sense it is cold enough there, so we can turn off the heater. Okay, or sometimes it is humidity is there, some heat is there, so we turn on the AC. So one feedback mechanism working inside us. Okay, which gives a signal to react on that one. Okay, so this PID controller designed based on that. Okay, so when we feel some cold, we turn on the heater, we press the accelerator. And one more example, we press the accelerator of the car whenever we are getting late. Okay, when we are moving somewhere, we are getting late, so we will accelerate the car. Okay, so this works as the control loop. Okay, whenever we make change any change in environment by sensing the previous results of that process, we form a closed control loop in our mind. Okay, this is the closed control loop which is working in our mind. Changing the speed of the car is one of the example. Okay, so with the help of this block diagram, okay, so we can see this is the design diagram of a block diagram of PID controller. Okay, so we are giving some taking some input from here. Okay, if it is going by passing this one. Okay, it is adding some having some algorithm and it is going. Okay, so it is going and it will take can be handled by some transfer function. Okay, so this is the proportional. Okay, kp t in bracket function of t. Okay, and it goes to the process and where and output will come. Okay, when output come over here, it again goes to this input as input function, and again comes to the at this point. If some error is there, if it needs some increment, so in integrative is there. Okay, or it needs some differentiation, it is the differentiation is there. Okay, if it doesn't need anything, it will go to again to the t. Okay, so this is proportional, this is integrative, and this is differentiative. This is proportional integral derivative. Okay, this is the PID control. So how we can use this with the help of Simulink? Okay, so you can see the different blocks are available over here. Okay, so you can just as I shown you and over here in the library browser. Okay, in the library browser, so this PID controller, this is designed by using these blocks only. Okay, so what is given over here, we can just go to this one. So first one is the continuous. Okay, so from this library, from this Simulink library, we will just take the continuous block. Where maybe it is not available in this continuous. This is continuous. Okay. This is the one. Okay. Then second one is the PID controller. Okay. So you can search over here. If it's not available, you can search over here. Okay. So all the blocks are available in this library. Okay. Customized blocks are also available. Someone is designing the panel of this car. Wi-Fi icons, callback buttons, check button, callback buttons, combos, displays, edges, okay, half gauges, knobs, okay. Different blocks can be drawn from these blocks, okay. So you can explore more with this one. I am just showing you the example, okay. Sync sources, ramp and concepts. So this is the step, okay, and continuous. So I'm moving ahead. This is the tutorial which is available. I will share with you. So one by one, you can take these blocks and drop over here. Okay, from this library, you can take this block and you can put over here like this. Okay, so it's already done by me. Okay, I'm deleting this one. So this controller is already made over here. Okay, so I'm just explaining you. So first of all, the starting, first we will take the continuous function, then we use the PID controller from this control box, then we will move ahead to this sources, and we will take the step function from here, step response. Okay, then after we will go to syncs. In sync we will take this scope. Okay, scope from this one. Scope is also available in this one. Okay, this is scope. Okay, we will see the output over here. Okay, now in between what we have, we have a transfer function. Transfer function is there, this one. Okay, a transfer function is there. Okay, it is already created by me. Then sum of this, if we want to add these, we have sum. Then after that we can edit these parameters, okay, by just double clicking on this one. Okay, so like 21, 10, 20, it is showing over here. Okay, it can be edited. For PID controller, okay, we can give the value of P 300, value of I 350, derivative is 10. Okay, then what we have, and so on, we can move on. Set the output as a step 0, 0, 1 we kept. Okay, and PID controller, as I shown you, 300, 350 and 10. Okay, so this block diagram of PID controller is completed. Okay, now we will run this one. Now we will run this one. Okay, so model configuration parameters also possible here. So if you want to see the fixed step with the step of 0.01, okay, 0.01, it is already done with this model. Okay, I will simply run this one. Okay. So it is showing 100%, means it is completed. Now we can see the all on clicking this. Okay, so this is the output of this PID controller, which is showing, okay, the time and displacement. Okay, 0 to 0.5 we have given already as a step response. Okay, so we can see this response is overdamped. Okay, so this is overdamped. How to overcome this overdamped function? So there is another method. This output we got. Okay, this output we got same as. So we can see this is the overdamped response. Okay, so this is overdamped, so we can just adjust it by tuning. The values which are given by P, I, and D can be used, and we can change the values of Kp, Ki, and Kd. Okay. So let's move towards the other methods. Place three gain blocks. Okay. So we can use these three gain blocks. Okay. It is also there or not in library. So another simulation block can be made. Okay. To overcome this problem. Let me see it. This one. It takes too much time to draw this one, so I'm using some inbuilt. Okay. So you can see over here this PID controller second. So what we are using in place of using that one PID controller, we are using different blocks. Now these gains can use KP, KI, and KD. Okay. So in the KI will be the integrator, KD will be the differentiator, P will be the proportional. Okay. After that we are adding over here, and the transfer function will be the same as we are using in that one. Okay. So you can see KP, KI, and KD are here, and then derivative we have taken. This derivative came over here. Then integrator also taken from this Simulink library. Okay, and joined together. So it will go to the transfer function. Okay. Now we will see the response. Okay. So we will see now the response is very clear. Okay. So now I will run this one. So you see it is showing 100%. Okay. I will click on this scope. So the response is now what we desired. So like this, we can design the PID controller, okay, with the help of this Simulink and toolbox available in MATLAB. Okay, like this is one of the example of a DC motor implementation using Simulink MATLAB. Okay, it is also possible in MATLAB. Okay, you can see the output of this one. It is also available in the library. I will just click on this one. Is related. Many examples are available with the MATLAB. So we'll see this is the uh, speed speed control PID block. Okay, this is the speed control PID block. So you can see number of blocks are used PID controller. Okay, so you can see over here this is the model of engine. Okay, engine intake model. You can see the throttle, manifold, induction of power and stroke delay. Okay, and combustion model also there, air charge model also there. Okay, air fuel ratio mixture are there. So if input is given as the reference, okay, in which initial value 2000 to 300 are given. Okay, so after running this one, we will see what we can see over here as the output. Okay, so from the speed varies between 2000 to 3200. Okay, so like this, it is also possible in MATLAB to design this type of controller. This is the brief introduction. For illustration also, you can make your own. Okay, so this is the experiment we are doing with, we are giving to the students to design a controller or something to draw in MATLAB. Okay, so now moving ahead. So this is the Simulink I briefed about this one. Next, we will see, I think this is blocks I have shown you, and how you can see what is the behind the curtain in Simulink. So you can see OD45 solver means the Simulink is based on the MATLAB only. The function which we are using, or the commands or the codes which we are using in MATLAB can be are used in as a inbuilt function in Simulink only. Okay. So bouncing ball models, and these are models are already available as example in library of the Simulink. one want to explore this one, they can explore. Okay, so these kind of results are possible in the this MATLAB simulating. Okay, so more math continuous, discontinuous, these toolbox are inbuilt in transfer functions are inbuilt in simulating toolbox. Sources things as I shown you. Okay, so I'm leaving this one over here, and now I will discuss some codes. Okay, so too much not much time is left. Okay, so these topics we covered simulink. I believed about simulink. Okay, now I will show you some experiment with the help of which we are teaching the students. Okay, suppose there is a you want to teach some shear force and bending moment diagrams to the students. Okay, or some heat transfer problem or some vibration problems to the students. Okay, so I'm just showing you an example of shear force and bending moment. So length, width, and depth are given for any beam. Okay, dimensions of beam are given. Okay, the loading conditions as point load are given. So first of all, what we will do, we will calculate the moments. Okay, and reactions. So this MA, MB, and MC are the fixed in moments, and RA, RC, RV are the reaction at the supports. Okay, now we will initialize this one. Okay, so SF, in SF it is calculating the shear force, and in BM it is calculating the bending moments. So it is the so what it contains. Okay, it contains a for loop. It contains a if else loop. Okay, so what we studied for brief about last 2 days. Okay, can be implemented over here. Okay, subplot we discussed. Okay, so if I am running this one, what I will get this kind of figure of shear force and bending moment diagram. Okay, so this kind of things we can teach to our students. Okay, for using this mechanics of structures problems and machine design problems, in which we are showing them shear force and bending moment plots. Okay, so we can see just giving we are giving defining some dimensions. Okay, then we are calculating some moments and reactions and giving it in a loop, which is calculating the shear force and bending moment. Then it is plotting with the help of some commands, subplot and a plots. Okay, title, shear force, bending diagonal, x level, y level. This is all we discussed in previous college. Now this can be used for problem solving also. Okay, so this is the one way. Next, again, we conducted some experiment like for this shear force bending moment only. So that is one for the point load. So it can be made for the simply supported beam with single point or the UDL. Okay. Some noise, sir. Some noise is coming. Hello. 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 Okay. Okay, so this code we can use for simply supported beam with single point load and UDL load. Okay, so in the previous problem we made just one problem, and we defined length, width, and all the things in that one. Okay, so unlike this code is different. Okay, so it will show you some display. Okay, so in it will show display. So in display it will show a simply supported beam is there. Okay, then it will show some input commands like length of the beam in meter. Okay, it will display. Hello. Okay. There is some interruption in between. Okay. So we can use we can display simply supported beam as display. We want to give input the length of the beam in meters. Okay. Then we want to display options, whether it is a point load or UDL load. Okay. So load case. Okay. So type equal to 1 will be the point load and type 2 will be for the UDL. Okay. So if the load is okay, so for it will show what we see. It will show simply supported beam, then length of the beam, then type of loading means load case. Okay, so it will take 1 for point load, 2 for UDL load. Okay, load case. Now it will take W load applied in kilonewton. Okay, then second input location of the load from the left end from the beam in meters. Okay, then it will calculate the R1 and R2, left support reaction and right support reaction. Okay, so it is under the loop, if loop. Okay, if condition satisfied, it will go again. Okay, now W will be take as input uniformly distributed load in kilonewton. Okay, kilonewton per meter. It will display length of the UDL in meter. Then it will ask, in case of if you given the command 2 for UDL, it will ask center of gravity of UDL from the left end of the beam in meter. Okay. So now it will based on the given input, it will calculate R1 and R2, which are the left support reaction and right support reactions. Okay. Then it will clear the discretization matrix. N equal to n 1,000 is given number of discretization of a x-axis. Okay, so increment for discretization it will be L by n. Okay, then generate column array for x-axis. Then V for shear force function of x, and M is function for bending moment. Okay, and we will initialize the data procession for the action. Okay, so we given V and M for the shear force and bending moment. Okay, for first portion, and it will calculate further if the condition will satisfy, not satisfy for this one, it will move ahead for this if loop. Okay, and it will be V22 and M22, it will save likewise, and at the end it will be come in x1 equal to a, and maximum moment will calculate by this one. Okay, then again it will go to the first portion of the beam and second portion of the beam. Okay, and at the end you can see it will be saved as x1 and mx. Okay, it will what it will show us at the end, it will show at the end left support reaction in kilonewton, right support reaction in kilonewton, and maximum bending moment in kilonewton meter. Okay, then subplot, what will show subplot? Subplot will show you two graphs is of one is there for shear force and one is for bending moment. Okay, so this is the plotting command we can use for further use for designing our output. Okay, so subplot 2 is there, 2 1 1, 2 rows 1 column, and position is 1, and for subplot 2 2 1 and position will be second. This is for bending moment. Okay, x comma m, and it is given x comma v. So v is for shear force, m is for bending moment. Now I'm running this one. Okay, so I'm running this one. So it is asking the length of the beam in meters. Suppose I'm giving, you can give anything. 100. Okay, now it is asking for the point 1 for point load and 2 for UDL. Okay, so I'm just first I'm typing for point load. Okay, now it is asking me applied load in kilonewton. Suppose I'm writing 30 kilonewton. Now location of load from left end of the beam in meter. So total length of the beam is 100 meters. Suppose I'm writing 25. Okay. So this is our shear force and bending moment diagram. Okay. So you can see at the 25 meter, it is showing the maximum bending moment, and in shear force, it is showing the condition from positive to negative. Okay. Okay. So this is the shear force for the point, shear force and bending moment for the point load. Okay. So and at display, what is showing output? The reaction at left support react 22.5 kilonewton and right support reaction is 7.5 kilonewton and maximum bending moment as you seen in the display. Okay. Now again I am running this one for the this time we will see for UDL. Okay. Length of the beam again I am taking 100. For UDL I will type 2. Then uniformly distributed load in kilonewton meter. So I will write as 40. Okay. Length of UDL in meter. So I am writing 30. Okay. Center of gravity of UDL from left end of the beam. So I'm writing is this one as 20. Okay. So this will be our shear force and bending moment diagram in case of UDL. Okay. So you can see the plot is showing curvature in case of bending moment diagram, and it is showing at 29.29 meter at 29 meter, and it is showing the reactions of 960 at left end and at the right end, and maximum bending moment 16,320. Okay. So like this small program we can show to the student for the structural problem. Okay. Now moving ahead, I will show you just for the example only. Example 11. Okay. So this one is the analysis of nonlinear heat transfer problem in thin plate. Okay, so for to run this one, it is very long program. So I will just show you how it is done. It is not possible to describe all the things. So first of all, we are describing the properties of this plate we are using: thermal conductivity, density. We will specify all these properties, specific heat of the material copper which we are using, thickness of the material, and Stephen Boltzmann constant which we are using, heat transfer coefficient which we are using, the ambient temperature, the emissivity of the surface plate. Okay. Now we will create the partial differential equation model with the single dependent variable. So we will initialize with this one. Thank you. Okay. And thickness, the geometry of the mesh with width 1, 1. So width and height are given 1, 1. Okay. Now we will define the the quality of the meshing for meshing purpose. Okay. So GDM as G is given over here. Okay. To define the geometry of the object. On doing it, so okay, it will show in the PD model. Okay. So and show on the PDD, you can explore this with PDG plot. Okay. Okay. With the help of this one, you will get the more information. So C with thickness into K and more so on. Okay. So after running this one, it will show me the state and heat of this copper plate. Okay. So we can see it is showing the geometry with edges labeled display E1, E2, E3. Okay. Then second figure, multiple plots are also possible here. Second figure is showing the triangular element match plate. The plate is with the triangular element match. Okay. Then what it's showing? It is showing the distribution of the heat throughout the plate from 450 to 1000. Okay. You can see 0 to 1, and in temperature it's increasing from 0 to 1 Kelvin, degree Kelvin. Okay. Next, this is for a steady state solution, and next it is showing temperature along the top edges of the plate as a function of time. Okay, so you can see as the time is increasing, the temperature also increasing in the plate. Okay, as you can see in the last figure. Okay, and this figure also showing for 5,000 seconds. Okay, it is showing for the 5,000 seconds that it is the transient solution. Okay, so what we see over here, it is many things are given over here: noodle, R solve, noodle solution, figure plot, then mesh dot nodes. Okay, so this is also possible in the MATLAB. We can teach this as a heat transfer problem. Okay, now coming for the last problem, 12. This is the mass spring damper problem which we teach to the students. I will show you over here. Okay, this problem, spring mass damper problem for unforced response. Okay, some mass is there which is connected through the spring and damper. Okay, if we are leaving this mass, so what will be the trajectory of that mass which is connected to this mass spring, which is shown with the help of this code. Okay, so you can see yesterday we discussed about the OD45. Okay, so this is with the help of unforced one is the function made for this one. Okay, it will take t span already given over here, t span and y0 as input, and it will return after the differentiation, it will return t and y. Okay, and we will plot t against y. Okay, so I am writing this one. Okay, so the function which is used over here is unforced one over here, which is here. Okay, so you can see this function which is over here, we are calling in this one, okay, OD45 unforced. So we got the response of like this one. Okay, so this is the displacement over the 50-second time. So now we can change this t span to simplify. So what I will get, okay, so what I will get, we will get less number of time. So the time is changed 0 to 5. So it will show the displacement of this mass with respect to this time. Okay, now I will change this 5 to 500. Now the response will be the different. You can see over the time the displacement will be 0. Okay, so we can, if you play with the MATLAB, it will show you the different possibilities you can explore and you can teach to the students. Okay, so this is for I briefed about the 4 experiments like CR4 bending moment, some heat transfer problems, some vibration problems. Like that also you can explore. Like that also we can explore the more problems in MATLAB. Okay, like this I have shown you. Okay, like we prepared the Viva questions for the students. Okay, after every experiment, what is FEM, what is nesting, what is damper vibrations. Okay, based on this experiment we conducted. Okay, and after that we can also, it is also possible to do meshing in MATLAB. Okay, if it is available, I will show you this program of meshing. Generate mesh. We can see this these all problems we reproduce to teach our students. Okay, how to create PDE. Okay, how to create PDE model. Okay, after that how to do meshing. Okay, after that how to refine the meshing. Okay, how to change the element size. Okay, how to change the element size, how to change the element numbers. Okay, the different elements are there. Okay, how to give the node numbering to each and every element. Okay, this is also possible. with the help of this tutorials, we can use these ones. Okay. Quality of the mesh, we can assess the quality of the mesh elements. Okay. So this will, with the help of this, again with the PD model, you can create the PD model. This is simple model. After that, you can mesh and do the meshing also. This one, you can the refine. We can refine the meshing. Then you can also evaluate the stresses. Okay, the nodal stresses, evaluate the stresses for a structural results. Okay, this kind of simple beam problem can be solved. Okay, for the normal stress distribution with a time step. Then structural problems to evaluate strain. This was for the stress distribution. This one for the strain distributions. Okay, uh, with respect to time. Then stress concentration in plate with circular hole. If any hole is there in a plate, okay, so what will be the stress concentration in that one? This kind of problem can also be taught to the students. Okay, for the lab purpose. Okay, there's a structural problem. This is the normal stress distribution along x direction. Then structural problems solving using deflection analysis of bracket. Okay, if any bracket is there, you want to solve the problem with the help of MATLAB. So some inbuilt command in this solved problems are available in MATLAB, MATLAB library. Okay, mesh with quadratic threaded elements with the meshing. The final element solution can also be possible in this one. Okay, can also be possible in this one. Okay, so this is distribution of stress. Okay, of this in x, y, and z directions, in all the direction. Okay, one Moises stress, the difference stress distribution is possible in MATLAB. Okay, deflection of simply supported beam with the help of the code. Okay, then this simple CRO bending they already taught you. The heat transfer problem with temperature dependent properties. Okay, this kind of structure we can make in MATLAB. Okay, you can see the FEM meshed FEM displayed in the block. Temperature of a steady state solution, distribution of temperature distribution in a steady state solution. Okay. At the end, thermal stress analysis of jet engine turbine blade. Okay, this is the jet engine blade. Okay, thermal analysis of this one. Then vibration analysis of a square plate. Okay, vibration analysis with the help of FEM. Okay, then thermal and structural axisymmetric thermal and structural analysis of disc brake. Thermal and structural analysis of disc brake. Both the analysis together, or one by one, first structural, then thermal, or together we can show. Okay. After that, last vibration analysis of dynamic analysis of clamped beam. Okay, dynamic analysis of clamped beam and dynamics of damped cantilever beam. Dynamics of cantilever beams. So we have shown after that the DC motor simulating model. Okay, this is also one PID control model. I have shown you how to create this one. So this is also possible. I will show you. Someone want to practice this one. Okay, so this is all about of this 3-day FDP program. Okay, so from with this one, I am concluding the 3 days FDP. If any question is there, Sheshaya sir is with us live. Hello, sir. Sir, now you can unmute. Unmute. Oh. Sheshaya, no, sir. Hello, sir. Sheshaya, sir.
Sir, good morning, sir.
Okay, sir.
It's very nice presentation, sir.
Okay, thank you so much, sir. You was available all the 3 days. I have seen you. as an active participant. Thank you so much for that, sir.
Yes, sir. Yes, sir. Yes, sir. So I am listening, starting to ending, sir, each and every line.
Yes, yes, sir. Yes, sir. Thank you so much, sir.
Sir, please share material, sir, as I will practice.
So, sure, sir. I will share, sir. If any problem is there, you can
Mm,
contact with me anytime, sir. Okay. I will share
mm,
all the materials, the structural problems and MATLAB basics and this thermal problem, vibration problems. I
yes,
will
sir.
share all the things. Okay.
Sir, Chaitanya is my classmate, sir.
Yes, sir. Sir told me, sir. Yesterday
Very good.
only Chetan sir told me that he is my batchmate, sir.
Yes, sir. Exactly. Nice, sir. Nice to meet you, sir.
I think, sir, Chetan sir is busy in some meeting, sir.
Yes,
Okay.
sir. Yes, sir. Just now she messaged me, sir. I am in meeting, so you can proceed like that.
Yes, 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 sir. Yes.
Mm.
Okay, so,
Very, sir. Sir, so how much time it will take to learn all these things?
sir, actually, it depends on your practice, sir, how you'll practice, sir. Actually, sir, we used to do these practice in MATLAB, this MATLAB in MTech
Mm.
time, some small programmings, okay.
Mm.
After that, in some conversion problems in PhD. So, if you do practice, sir, it will be very easy, sir. Okay.
Sorry, you told now meshing and the analysis part. So why they developed a mechanical APDL as mechanical analysis abacus? So what's the difference between this MATLAB so results and mechanical APDL results?
Sir, that is different, sir. That is some inbuilt blocks are available in your if you are talking about this APDL and ANSYS and another types of analysis are possible. Okay, but
Uh,
MATLAB is very vast, sir. Okay, okay.
but here also
So
you see now something meshing and analysis
yes,
part.
yes, yes, sir. Yes.
Thanks.
Okay, sir. We have Kalyani ma'am with us. Okay,
Okay,
for
sir.
vote of
Thank you, sir.
thanks.
Good morning, everyone. This is Kalyani. Since the starting of the session, I'm also with our organizing committee and with Professor Dr. Singotia sir. This is a great privilege for me actually to deliver the vote of thanks for this 3-day workshop on MATLAB. Hope you all enjoyed the session. And hope this session is very fruitful and so many different concepts and also so many exercises and for the day-to-day practices sir has taken this task very seriously and he has given an insight for us and basically the preliminary or the person who is not having the knowledge also can able to understand this lectures in this way. Thank you very much. I would like to thanks, sir. And apart from our, on behalf of our department, we would like to thank Dr. Pawan Singotia, sir, for delivering the lecture and for giving us the insight on this is very good session. And hope I think everyone have enjoyed this session. And depending upon the feedback, we can assume that you all are very happy with this lecture and the session. And now I take this opportunity to thank each and every participant for patiently following the session and making this FTP very grand success. I would like to thank the resource person of this FTP once again, Dr. Pawan Singotia sir, for sharing his valuable knowledge and for his valuable time also even. I also thank our HOD and principal for their endless support in carry on this session. And last but not the least, I thank all our faculty members and technicians for the support and cooperation. Thank you, everyone. I hope for the next coming episode, for the next coming sessions also, we would like to see these many participants. And special thanks to our resource person, Dr. Pawan Singotia, sir. Thank you very much, sir. Happy learnings. And again, we would be in touch with you all. Thank you all. Signing
Thank you
off.
so much.